So this is only possible now, since a few years, because you have such a computation power into small microchips.
Kollegen Minh, AI Solution Architect at EFS. Today we're going to talk about Federated Learning and Edge AI, some incredible innovative topics and approaches in the field of artificial intelligence. I'm your host, Ralph Zlabinger, and I wish you a lot of fun with the following episode. So, hello Minh. It's a pleasure to have you here today. How are you and how did you come here today?
Yeah, hello Ralph. Thanks for welcoming me. I'm okay. I've finally had some breaks, so I'm back on track. And I came with my electric scooter.
Good. So today we're going to talk about artificial intelligence, very specifically about the topics Edge AI and Federated Learning, because Minh, our guest today, is an expert on this topic and an AI solution architect. So we want to learn more about this because this is a very special approach to using AI and applying it. So maybe, Minh, you can tell us, how did you actually come to this topic and how did you anyway got in the field of artificial intelligence?
Well, I came naturally to the AI topic because of my research on how to certify data and how you can trust data, because I found out that most of these data will be analyzed and will be actually handled by AI or machine learning systems for triggering actions. And in the reign of safety-related machines like cars, it makes sense actually to be more aware about how you feed this kind of models and how they're working. And I was also really interested in the other way around, how you can use an AI as a human interface for handling complicated machines. So it applies to the industry in general, because suddenly you make a shortcut. You don't need engineers anymore. If you model in AI, and I made some tests for data loggers, for example, for cars, if you give them the instructions how you can handle access data in a car, which is quite complicated, you need an engineer normally and so on, and you give him some examples, and then you just ask him, give me, extract this kind of data from the car, make this computation even from a fleet of car, and give me some results. It was actually able to give a code and to execute the code on direct, I would say, a machine for this. And this is also another aspect, I think, which is accelerating the adoption, is suddenly you're coming out of this classical IT development buckle. You're shortcutting actually the approach from product owner to the product. Because if the domain-specific people know what they want, they just have to express it to a domain-specific AI, which is able to actually to code and make the application itself. So I find this really fascinating and interesting. Me coming actually from a product owner and creation of new products world, where you can actually shortcut these things, and also the critical phase, of course, related to data and to fulfilling this kind of models. And this is why I landed here in the EFS, because we had a common project, which was related to CAN data and car data. And by seeing the rise of these things, I think it was also a great time to work with you guys here.
Now we got right to the point where you come in with a very special approach to AI. It's called Edge AI. It's in combination with the architecture called Federated Learning, and also working with making sure that your data is certified, so data is safe to use. So let's dig a little bit into that. So maybe let's start with Edge AI. So can you explain the concept? What does this actually mean? And how would it help, for example, to solve the problem of autonomous driving?
Edge AI means actually it's just like edge computing. Edge means it's mostly embedded into the IoT device, which is in this case a vehicle, and is able to run actually an AI model, an analytics or computation directly into the car itself. So this is only possible now, since a few years, because you have such a computation power into small microchips. The last smartphones have the power of our best laptops for 2 years ago, and can do anything, and doing a lot of AI already. And pretty much every next smartphone will have the capacity of ChatGPT-4 directly offline embedded. So you can imagine how these things are evolving in that direction. So this enable really solve two major problems for connected car and connected vehicles for this kind of thing. It goes back actually in what I've done before. It means that you, instead of throwing data into the cloud for triggering computation analytics on machine learning, on predictive maintenance, and all these use cases. Then now you can do it in the car itself. So you're also reducing the risk of attacks on the data itself because it remains on the car. And you have access to these models offline. You can be in a garage, you can be in a desert. Some mining engines are already using this kind of technology. And the other big aspect of this is it enables also the car to not transmit any data anymore. So you can start making analytics on things where a bit the big dream, or I think the big topics for many services like driving behaviors, health status, that are really useful for insurance use case, for security and safety, autonomous driving reactions, or at least driving assistance reactions and so on. And because it doesn't leave the car, it's in there. So there's the other aspect of this. It's how you actually update this kind of model and how you handle this. Because, for instance, for now, some brands did it for predictive maintenance, which is machine learning based. But you can also limit this only limit this for the moment to some part of the car that you have to target, because you had a lot of data coming out of a car, and they did it in the cloud for the moment because you couldn't do this in the car. So it means you have to upload a lot of volume of data, and the model is actually outside of the vehicle. And when you want to update this kind of system, you can only update this in an asynchronous way. It means that, for example, I think most of the predictive maintenance models are updated when a car has a problem. It comes to the garage. You see the context of the errors you have in a car. You can relate it to the problem you have on a brake or something else. And then eventually the garage will upload this information back to the cloud of the OEM, which will add this kind of data or knowledge to the machine learning model, and they will trigger a machine model for this particular part, for the fleet of this model of car, for predictive maintenance. But you see the problem of this is extremely asynchronous, and it's also very slow in terms of reaction. So the big thing for this kind of thing is, of course, the target is to avoid big recalls of cars for problems, and so on and so on. So you have a Swedish brand who already switched from this kind of model. They were lead on this because they could see that they couldn't scale on this. And AGI is actually one brick in this way to handle this differently, which enabled this kind of thing. So then we can talk about how you use this in a different approach and architecture.
Exactly. So I guess now we're coming to the federated learning. So AGI is the general technological approach. It means that the computation happens at the machine itself. Mm-hmm. But this is just the one problem. This also, as you said, is still not the full story, because you still have to get the data somewhere or whatever it is. So and federated learning then helps us to actually make the process more synchronous and faster. And also the way it's done, I understand you found also a way not to actually have to share the data with the cloud, but actually to do something else. Maybe you can explain that, yeah?
Yeah, exactly. I mean, the federated learning is also there since a while on paper. And I think especially for the industry, it's recently only enabled also by partner which are developing this kind of open source framework, which is Flower, which we're working with. You need actually an approach where I try to explain. It's really simple actually. Imagine you have a fleet of car, and you want to apply a predictive maintenance model for a specific part, let's say a brake, and you already have a model that you fine-tuned before, and you have a fleet of cars, or let's say commercial vehicles in that case, where you dispatch or deploy this model to these different cars in their own AGI chipset. So the cool thing is every vehicle has on board this AI, always available. And then you can also implement maybe a continuous learning in every car. It means if you have a new context, and this AI can actually also, let's say, decide that this new context is related to this part, and it can actually transform this into a AI knowledge, which is most of the time just weights of vectors, and it will be able to transmit this new knowledge back to the central model, which will then decide how to merge this new knowledge and to dispatch it again to all the other fleets. The great thing in this approach is suddenly you automate the fine-tuning and I would say increase of quality of the model automatically between in the fleet, because it also means that the more fleet participants you have, the faster and the better models you're going to have at the end. So you really have this hive intelligence coming up, which is completely opposite to the cloud approach, where the more participants you have to invest more in infrastructure, more in computation power, and there's a critical number where suddenly the performance will really, it costs first, and also the performance will not be so good anymore. And here it's a decentralized approach in that case, and also it also enables you on the edge to display this to more parts, to other parts on break, and more, and without actually increasing the general computation power, because the computation power is actually decentralized into every vehicle, and this is really, I think, solving the major issues in connected vehicles and applications of machine learning on AI applications, where the two major blockers are, first, transmission of volume of data you need to transmit to cloud computing things and back and forward. So asynchronicity and volume of data problem, which is solved there because you don't send any more data, you just send few kilobytes of weights of vectors. And also the fact that the automation between the participants for fine-tuning the model, it's completely automated by the machine itself, and you can program this into the federated learning model itself. So you have different techniques and so on. And this is actually now an approach which is already implemented to one car manufacturer, a major one. It's already implemented to health, of course, because you have the same constraints, privacy problem with data, and also trust. And the last factor here is also you can suddenly analyze really private or sensitive or safety-related data without infringing any GDPR or industrial secret things and so on. And you can even start sharing knowledge and models with your competition, because you have a win-win situation in that case, because in some topics it makes sense for the general safety and so on.
That's a very interesting approach. I will try to, again, put it into my words. So on the one side, Edge AI means that you have the computation directly on the machine that you want to gather information and data from. And federated learning means that you then don't send the whole data set somewhere to a cloud. You basically just share what this algorithm, this Edge AI has learned, and you just share it in form of a vector with the cloud. So the cloud is only there for updating knowledge and spreading it again.
Yeah, eventually the cloud is just there for hosting the central model, which then decide how to aggregate actually different knowledge coming from the different participants, in that case, fleets. And the Edge AI is the one who is doing the analytic and sending only weights on vectors to the central model. Yeah. So on the end, you're only transmitting vectors and data. Yeah. I mean, good luck if you hack this kind of data, you can do absolutely nothing out of this, I guess. Plus you can add encryption layers if you want to. And the big benefits at the end is also you have pretty much a real-time update of the model. So it means that all the fleets has always the best machine learning models on this topic and so on. There are some stuff which needs to be faced also. Same for the data. Here you need also to make sure that the participants in this kind of networks of federated learning machines, that all participants are legit, that you can also trust the kind of analytics they're doing and the kind of weights, because you have a risk of, let's say, poisoning actually the models through fake participants or fake weights. You have the same issue here. So we are coming back here on my concern, also my knowledge experience of how to make sure that a machine first has a real identity. There is a hardware also problem, like was for the hardware, where blockchain I think is really useful, because in that case you can, with a piece of hardware like in your iPhone or any payment system you have, it's actually a piece of hardware, which is a secure element, which has its own private and public key. You can sign on the blockchain what you're transmitting as analytics, so you can make sure that what you receive from this kind of machine or vehicle is legit in terms of provenance. It's this car, not another one. And secondly, that the data and the analytics what you receive from this is also legit and haven't been tampered, because this is what enables, for example, the blockchain approach. You can write actually the hash of these data into the blockchain, and you can also always verify that these data haven't been tampered. So, I mean, this combination, which sounds a bit complicated, which is actually really simple, is 3 points. It's trust in the vehicle, the identity, which give you trust in the data because you can sign the data, which are not data anymore, but only knowledge transmission from AI to AI. Because in this case, you're enabling certainly, you only make communication from one AI model to another one, which is then displaying to the other ones. And there was no human intervention in the problem and no possibility actually to, let's say, hack or to tamper anything in the process.
Mm-hmm. So I understand we're currently publishing an article on the topic of Edge AI and federated learning. What will people find in this article?
Yeah, I'm working now with a really great engineer and researcher by the Flower AI framework, which is one of the open source reference framework and most used framework there. And actually, how this can benefit to a fleet of fleet of cars. In that case, more commercial vehicles, because this is mostly where they have fleet. And we concentrated actually on one use case about predictive maintenance on specific part. And I validated with them how we could use this kind of approach. On one side, the AI technology combined with their Federated Learning framework, which has a new version recently. And it's going to be published soon, and also to see how it's possible, because it's one of the work I think which is really important to do, how you can simulate actually a fleet of vehicles with data that the OEM or the fleet managers can decide what kind of model they want to deploy there, and how this could work actually in the future in reality. And there are some framework who are already doing this in a way where you can simulate and fine-tune your model, and you just have to push a button, you deploy this on your fleet, and it starts like in your simulation, but in the cars. So this is, I think, it's a really promising direction for commercial vehicle, for uptime. Predictive maintenance is the hanging fruit on this story, but there are many, many other aspects. Yes.
Let's still come to the very important question now. So what if now somebody who would listen to this, or one of our potential customers, got interested in the topic? So what would we bring on the table if a partner says, okay, guys, sounds great, I want to know more about that. So how could we serve our customers in this way? Well,
we have already some customers who are, they have interest in this approach. And what we're providing is clearly, well, for their particular context, and see also how far they are already into how to secure the data, how far they are, because most of them are already doing machine learning for mostly predictive maintenance and all these things, because they have the real benefits already on this, how far they are into this kind of implementation. Most of them already facing these issues I'm mentioning in terms of scaling, because it's the way it's built for the 30 years of legacy we have. We believe everything around the cloud has its limits, and now we have technologies who are enabling to have a completely different approach on this. So what we're doing is we first informing them what is possible now, and then we also starting doing an architecture of one of the use case where it has really impact and benefit for them. And we're also bringing up the right partners, what we're working with. We're going to publish something together, like with Flower or Streamalize in Sweden, which are doing AGI technologies, which is actually AGI in real time on CAN data and so on, to also doing a prototype, which is really important for us. Meaning, because with a prototype, you're facing the real reality first on the hardware side, on the data side, and the client is also facing their own limits or maybe transformation needs into their own infrastructure and processes to get there. So, and that they also have something they can measure at the end with some metrics where they can also decide after a while, well, it's worth it to invest in that direction because we can have that much gain in time, in cost reduction, tell them. And this is pretty much where we can really support, because I think we have 30 years of legacy in automotive, so we know how it works. We know also the internal process and the difficulties sometimes where the OEM have to transform themselves for these kind of topics.
Okay, Minh, this sounds very interesting. So how can somebody now get in touch with you personally if he wants to discuss this topic with you from face to face?
Well, I think they just contact you guys from EFS or myself. Well, I think I'm on LinkedIn. I'm also in the company. You can just contact me. And of course, I'm open to any discussion in that direction. It's pretty simple.
Minh, thank you very much. This was incredibly interesting and informative. And I hope we can follow up on this. I think there are some other AI topics where we can talk about, such as AI agent architecture and so on. So thank you. And see you soon on this podcast.
Thank you.
Thank you, everybody, for listening in on this latest episode of the EFS podcast. Stay tuned for more and see you soon. I'm your host, Ralph Zlabinger. Bye-bye.